Welcome back, everybody. Continuing our graphing of quadratic functions. Today we're going to work on vertical shifts up and down. Pause the video and take a minute to jot down your vocabulary. Our first example, we have x squared minus 2. Comparing it to the x squared. So the x squared is our parent function and the minus 2 is what's happening to our graph. To find out our new coordinates, we are subtracting 2 from our y values on our table. So if I start again with our same -2, -1, 0, 1, 2, 4, 1, 0, 1, 4, then we are subtracting 2 from each of these values. 4 minus 2 is 2. 1 minus 2 is -1. 0 minus 2 is -2. -1 and 2. To make our graph then, we have ordered pair of -2, 2, right there. -1, -1, right here. 0, -2, here. 1, -1, which is here. And 2, 2, which is here. Making sure again that you're writing that as a U, not a V. This is opening up. Our y-intercept is at 0, -2. We do have some x-intercepts. They're decimals, so we would estimate them. And if we're estimating, we're not going to write x-intercepts down. Our vertex is the lowest part of our graph, so that's still a minimum. Our vertex, that lowest point, is down here at 0, -2. Our axis of symmetry is still x equals 0. The x value of our vertex is still there. How many real zeros are there? So real zeros are x-intercepts. So we have to be able to see them on our graph. And we can see x-intercept here and here. And again, we're not really sure what those are, so we're not going to answer that part of the question, but we do see 2 real zeros. Our domain is still -infinity to infinity because we still have our arrows here at the ends. Our range, we're opening up, so y is greater than or equal to, and the y value of our vertex is -2, so greater than or equal to -2. Now, if we look back to our parent function, and I'll go ahead and I'll sketch our parent function. You don't need to put this on your paper. I'm just making a quick sketch here that looks like this. So the orange to the green, what happened to our graph? Well, the graph went down 2 units. So the -2 in our equation moved our graph down 2 units. Let's try the next one. We're still comparing this to the x squared. So there's our parent function. We have a 4 that's new and a +1 that's new. So remember, the 4 in front means we multiply y by 4 and then add 1 to the y values. So those are the two things that we have to do. We're keeping the -2, -1, 0, 1, 2. And I'm going to make 3 spots here. So our parent function, I'm going to mark with P, was 41014. Then we multiply by 4 because we're always doing our transformations from left to right. So 4 times 4 is 16. 1 times 4 is 4. 0 times 4 is 0. 1 times 4 is 4. 4 times 4 is 16. And then we are adding 1. 16 plus 1 is 17. 4 plus 1 is 5. 0 plus 1 is 1. 5 and 17. So graphing this, we're using the ordered pair 2, 17. Well, that's way off this graph, so I'm not going to be able to graph that. -1, 5. -1, 5. 0, 1. Here. 1, 5. Here. And then 217 again is way off the graph, so I'm not going to be able to graph that. I know it's going to be a very skinny U here. And there we go. There's our graph. This is definitely opening up. Our y-intercept, where our graph touches the y-axis, as at 0, 1. We don't have any x-intercepts here. Our vertex is a minimum. Our vertex is at 0, 1. Axis of symmetry is at x equals 0, because remember it matches the x value of that graph. And we don't have any real zeros because we don't have any x-intercepts. This graph does not cross the x-axis. Our domain is still -infinity to infinity. Our range, direction is opening up, so greater than or equal to. And our lowest y value there is 1, matching the 1 of our vertex. And so what transformations happen? Well, we multiplied by 4, it got skinnier, it stretched towards the y-axis, and so this is a vertical stretch of 4, and then it moved the whole graph up 1 unit is the +1. Example 3. Still again comparing this to our parent function of x squared. So here's the x squared. We have a -0.5 in front and then a +2 at the end. We are multiplying the y by -0.5, then adding 2. Again, keeping that -2, -1, 0, 1, 2. We have our parent function was 41014. So times -0.5, or -1/2. 4 times -1/2 is -2. 1 times -1/2 is -1/2. 0 times -1/2 is 0. We have -1/2 and -2. And then we are adding 2 to each of those. So -2 plus 2 is 0. -0.5 plus 2 is 1.5. 0 plus 2 is 2. 1.5 and 0. I'm plotting these. We have -2, 0. There. -1, 1.5. Which is about there. 0. Sorry about that. 0, 2 is about right there. And then we have 1 and 1.5 and +2, 0. So here is our graph. This direction is opening down, and we would know this because of that negative in front of the 0.5. Our y-intercept is at 0, 2. Our x-intercepts we can see clearly at negative 2, 0, and 2, 0. This vertex is at the very top of our graph, so this is a maximum. And that vertex is at 0, 2. Our axis of symmetry, x equals 0. How many real zeros? How many x-intercepts? How many times does our graph cross the x-axis? And that's going to be 2. And we know that they're at negative 2, 0, and 2, 0. So the real zeros and the x-intercepts should always be the same. Our domain is negative infinity to infinity. Sorry about that. Our range, because it's going down, is less than or equal to, and our top y value there of our vertex is at 2. So this was an x-axis reflection because it flipped upside down. The graph got wider. It shrank away from the y-axis. So this is a vertical shrink of a half or 0.5, and then the graph went up 2 units. Please try the U-Try, and we'll see you tomorrow. Thanks so much for joining me. Have a good night.